Hey everybody, Mr. D here. Just wanted to check in with a binomial theorem expansion question that's located in the review for January's mock exams. You'll see that it's number 6. More specifically, I'm going to focus on part A, the binomial expansion, because that's where I think a lot of marks, the easy type of marks, can be achieved. So I'd like for you to take advantage of that. So here we go. 2 plus x exponent 4. The first thing to recognize is that we have some support in the formula booklet. So I've already gone ahead and found the area of the formula booklet that actually applies. So we have something here that looks very similar to the question we're asked for in 6a. And I'm going to take it a step-by-step approach. First thing to recognize is that because the exponent's 4, we're actually going to have 5 terms in the expansion. So in the case of n exponent, that means you're going to have n plus 1 terms in the expansion. That's a generality, and it applies. So to begin, I state that just as a reminder to myself. And then what I do for instructional purposes in this video, I set the table using this notation where n is 4, because that's our exponent. And then I fill in all the terms, coefficients in this notation. So understood in here is 4c0, and then 4c1, 4c2, 4c3, etc., until you're matching up 4c4. The reason why I'm saying 4c4, etc., is because in our graphing calculator, that's the terminology that's used. It's NCR. Although this is paper 1, it's still worth noting for subsequent questions that may appear in paper 2. So the next thing we look at is descending powers of n and increasing powers of n. And this is what I mean. So I take our first value here of 2. Start with 2 and then start with exponent 0, and then 2 exponent 1, 2 exponent 2, 2 exponent 3, 2 exponent 4. With the second term, plus x, so it's positive, we're going to start in the opposite side and build our exponents, starting with exponent 0. So it's going to read like this. X exponent 0, which isn't shown here because its value is 1. X exponent 1, x exponent 2, x exponent 3, x exponent 4. That's how I'd recommend you construct the expansion. It's the most straightforward method and least prone to error. Then from there, you're using prior learning to simplify. It must be noted, however, that the 4c3, 4c2, 4c1, etc., those values can be achieved through Pascal's triangle, the coefficients of the Pascal's triangle. You just have to make sure that you select the row that has 5 terms in it. So moving ahead, just doing some housekeeping, simplification, and using the formula booklet for the NCR notation, you'll get an answer of, for 4c0 is 1, 4c1, once you use this formula here, you get an answer of 4. 4c2 actually did for you just to show you that you take the number up top, factorial, divided by the number at the bottom, factorial, times the difference between the two. So in this case here, it's 4 and 2, which will give us 2 factorial again, and then just continue along simplifying. And I've actually gone ahead and just done the simplification, and you'll see that this value here of 4 factorial divided by 2 factorial, 2 factorial yields an answer of 6, but when multiplied by 2 squared, will provide an answer of 4 times 6 of 24, and the rest is just simplified. Something worth noting before I sign off is that the x values will usually have some pattern in terms of their exponent. So it looks like here we started with 4, and then descending to 3, 2, 1, and then x exponent 0. There should be some sort of pattern. It may not always be subtracting by 1. Sometimes it'll increase by 2 or increase by a half, depending on what the original values were in the term. But there should be some pattern that it's consistent throughout the terms for each question. Although the pattern, as I said, may vary from question to question. Anyway, I hope this helps. Please stay tuned for more videos. If you have any requests, please send them along via email or in person. We'll see you later.